Hi everyone. In this video, I want to briefly go over graphing exponential functions. So an exponential function is just some function of the form f of x equals b to the x. And typically we're considering, well, not typically, in all cases in this class, b is going to be a positive number. Okay? So I want to just kind of go over how we'll go about graphing these and just maybe examine the behavior for different values of b. So let's take a look at f of x is equal to 2 to the x. Okay, so we're going to graph this just like we have lots of other functions we've seen in this class. We're going to create a table and we're going to plot points. So let's start with f of x is, or sorry, f of 0. Okay, so if we start with x equals 0, we have f of 0. So we have 2 to the 0. Okay, and anything raised to the 0 is just 1. So we're going to have the point 0, 1. All right, so on the x-axis here, we're going to have the point 0, 1. Okay, and then if we have x equals 1, we'll have 2 to the 1, and anything raised to the first power is just itself. So we have 2. So we'll have the point 1, 2. Okay, so if we take the point 2, we'll have 2 raised to the 2. So we have 2 squared, which is just 4. And that's going to give us the point 2, 4. Made a mistake here with this last one. That should be right here. Sorry, 2, 4. Okay, and then if we do x equals 3, we'll have 2 to the third, which is just 8. So we'll have the point 3, 8. Okay, so what we can see is that this is actually growing quite quickly. What happens if we go in the other direction, maybe 2 to the negative 1? So here if we have 2 to the negative 1, for x equals negative 1, we'll have 1 half. Remember, if you take something to the negative power, you just simply, if it's a fraction, you flip the fraction. But if it's a whole number, you just do 1 over that number. Okay, so we'll have 1 half. So that's going to give us the point negative 1, 1 half. Okay, so that'll look like that. And then negative 2, we'll have 2 to the negative 2. That's going to give us 1 over 2 squared, which is 1 over 4. So we'll have the point negative 2, 1/4. So that'll look about like this. So the basic shape of our graph is going to be as follows. Okay? So as we go to the left, as the numbers get smaller, or more negative, I guess I should say, this is going to get closer and closer to 0. If we go 2 to the negative third, we'll get 1 over 8. 2 to the negative 4, we get 1 over 16. And what you'll notice is that's going to get smaller and smaller and smaller the bigger the negative numbers get. So it'll get closer to 0. It's important to note that it will never cross the x-axis here. It will never be 0. It'll just get infinitely close to 0. And then as we go to the right, it's going to get infinitely large very quickly. These get very large very quickly. So if we were to keep going in the positive direction, we'd have 2 to the 4 gives us 16, 2 to the 5 gives us 32, 2 to the 6 gives us 64. So we're doubling each time. So each individual step in the x direction, we're going to double the size, at least for a base of 2. Okay? What about g of x equals 1 to the x? Okay, so I will say there's typically a reason why we don't usually consider instances where we have a base of 1 like we do here, and I'm going to show you why. They're not very exciting. So if we have x equals 1, we'll have 1. X equals 0, we'll have 1 to the 0, and anything to the 0 is just 1. It's just 1. So we'll have the point 1, 1. Okay, that's reasonable. Okay, but what if we have x equals 1? So we have 1 raised to the first power. That's also 1. So this one should be 0. Made an error here. Should be 0, 1. And then this one here should be 1, 1. Okay, how about x equals 2? We have 1 raised to the second power, so we have 1 squared, or 1 times 1, which is just 1 again. So we get the point 2, 1. Okay, maybe we're noticing a pattern here. Okay, if we have the point x equals 3, we'll have 1 to the third, which is 1 again. So we'll have 3, 1. Okay, and if we do maybe negative 1, we'll have 1 to the negative 1. That's 1 over 1, which is just 1. So we'll have negative 1, 1. And then negative 2, we get 1 to the negative 2 is 1 over 1 squared, which is just 1 again. So we'll have negative 2, 1, okay? So we get what we call just a constant function here. So we don't typically call it an exponential function if we have a base of 1, okay? So if it's 1, nothing is going to change. It will always be a constant value of 1. But what happens if we have something that's less than 1? Say maybe 1/2, or really any number less than 1. It will have a similar shape to what we're looking at here. So let's try x equals 0. So we'll have 1/2 to the 0. And anything to the 0 is just 1. So we'll have the point 0, 1. So that'll look a little like this. Okay. And maybe we have the x equals 1. So we'll have 1/2 to the 1. So anything raised to the first power, as I said before, is just itself. So we have 1/2. So we'll have the point 1, 1/2. Okay. How about 2? We have 1/2 squared. So that's 1/2 times 1/2. So we'll get 1/4. So we'll have the point 2, 1/4. Okay, so it'll look about like that. Maybe 3, we'll get 1/2 to the third. So that's 1/2 times 1/2 times 1/2. That's going to give us 1 over 8. So we'll have the point 3, 1/8. So it'll look like that. What about negative 1? So if we have 1/2 to the negative 1, remember, if it's a fraction and we raise it to the negative 1 power, we just flip it, okay? So we're going to end up with 2 over 1, or just 2. So we'll have the point negative 1, 2. Okay, and how about 1/2 to the negative 2? Well, remember here, if we have something raised to the negative power that's not 1, say it's negative 2, like here, you flip it and then you make the exponent positive. So this will give us 2 over 1 squared, or just 2 squared, which is 4. So we'll have the point negative 2, 4. Okay, so this is the basic shape of our graph here. Okay, so once again, we're getting closer and closer to 0 as we go positive this time, and it's getting bigger and bigger as we get smaller. So so we come away with a basic conclusion. If our so for f of x equals b to the x, if b is greater than 1, then f of x is going to go to infinity as x goes to infinity. Okay, so it's going to get infinitely large as x gets large, right? So as x gets bigger, it's going to get bigger. And if inversely here, if we have if b is less than 1, or I guess I should say more specifically, if b is between 0 and 1, because we can't have b being a negative here. So if b is between 0 and 1, then f of x is going to go to 0 as x goes to infinity. Okay, and we're going to pull up some graphing calculator software here so I can show you what this is going to look like. So I have a little function here set up, or I had a function here set up. It must have disappeared. We can make one real quickly though. We have a to the x. Okay, and let's just see what this is going to look like. So if we have, let's change the step size here. We'll start it at 0. And we'll make the step size here pretty small. Okay, so if we're going to drag the slider, if we start off here with maybe a very small base, okay, so something very close to 0, what we see is a very steep curve here. So we're going to get very big very quick as we go to negative infinity, right? So as we go to the left, it's going to get huge. Matter of fact, you can't even really keep up with it on this graph. You can go to all the way to negative infinity, but it's going to get almost immeasurably large. And what you'll see is as you get bigger to the right, it's going to get very small. Maybe we'll see it a little better if we make the base a little bigger, but still not quite 1. You see, as we go to the left, this is going to get very big. And as we go to the right, it's going to approach 0. Okay? But it doesn't, we're never actually going to hit 0. We're going to just keep getting closer and closer and closer, but we're never actually going to hit it. Okay? So What happens if we go the other direction, though? So if we start to change this, right, as we go closer and closer to 1, see, we get our constant function here right at 1. And then it's going to shift the other direction where it's going to get larger and larger as we go to infinity now, okay? So, and again, you can see it here. As we go to negative infinity, we're going to keep approaching 0 without ever actually hitting it. And as we go to positive infinity, it's going to get very big very quickly, okay? So this is the basic behavior of an exponential function, okay?